Okay, so if you had to watch the video from Friday, I was told that the video I showed during class the sound didn't pick up right, so I put it as a separate video in the playlist so you can go back and watch it and you know what the heck is going on. All right, so today we're going to look at limits by factoring and rationalizing. If you are watching the video, chances are pretty good your set of notes only has one side on it because my copies were done wrong and I didn't realize it until this morning. But the good news is it'll be easy for you just to write on the back, even if it's blank, you can still keep up. But definitely do the back when we get there. So we have been looking at limits graphically, basically. And that first day that we did it, I did do a little bit of it by direct substitution. We talked about that sometimes you can just substitute it in and boom, there's your answer. But that doesn't always work. And I did show you one that didn't work. We factored it, and I showed you got 0 over 0, that whole business. But that's really what we're doing today. So we're not going to look at any graphs today because we need to know how to do it multiple ways. We need to know how to do it graphically from a table and then also algebraically like we're doing today. Okay? So what if that direct substitution doesn't work? So what to do if it's not possible? So suppose you're asked to find this limit right here. And if we substitute in 3, it says direct substitution is not possible because 3 results in 0 in the denominator. However, this does not mean the limit does not exist. Not only do we get 0 in the denominator here, we get 0 in the numerator. So we get that 0 over 0, which we did talk about the other day, but I use these words, but we didn't write them down or anything. It's described as having an indeterminate form. Okay, so indeterminate form does not mean that you cannot find the limit or that the limit doesn't exist, but we can apply other algebraic techniques such as factoring or rationalizing to divide out a common factor. So our instructions say to evaluate each limit and to verify with a graph or table. We're not going to actually verify with a graph or table. You can if you want to. We're just going to look at it from algebraic. If we were actually doing this to move a little farther with whatever the limit is in calculus, we would first actually do direct substitution and show that we get the indeterminate form. Then we get 0 over 0, and then we move on to the next step. We're not going to do that on these just because I'm going to tell you right now they all end up in 0 over 0, and then that's just more work that we don't need right now because we're trying to learn the limit part of it. Okay? So you just know that the ones I'm giving you, that's what would happen. That's why we have to go a little bit farther. Okay? The other thing to remember is that notation is hugely important here. All right? So that whole limit as x approaches 3, we have to leave it there and rewrite a whole bunch of stuff that some of y'all aren't going to want to rewrite because you're lazy and you think you can just have chicken scratch all over the place. But your notation and your form of your answer is very important. So when we look at number 1, we would get 0 over 0 if we substitute it in. So then we factor. So I say this equals, I have to rewrite the limit as x approaches 3. I'm not doing anything with the numerator. It's just x minus 3. Then I'm going to factor the denominator. That 15 is negative, so I know that my signs are opposite. So that would be a positive 5 and a negative 3. Okay. So then when I factored, now I can actually reduce that fraction. So I can cancel this with this. And that gives me a limit as x approaches 3 of 1 over x plus 5. But notice I had to rewrite the limit as x approaches 3 each time. Now I'm going to actually evaluate the limit with direct substitution, which means all I do is plug in that 3. When I do that, that's when I get to drop this part right here. And this becomes 1 over 3 plus 5, which is 1/8. Remember, like I said the other day, that's like when we take the square root of 25, the answer is 5, and the square root symbol goes away because we evaluated the square root. Once we evaluate the limit, that's when we drop this statement right here. Okay, does that make sense? We good? All right, we're going to skip number 2. Let's look at number 3. All right, so this will be equal to the limit as x approaches 2 of, in the numerator, this would give me x and x. This is positive, so the signs are the same. This is negative, so they're both minus. And it would be minus 2 and minus 3. And in the denominator, what's that situation called? something about squares, right? Even if we don't know the name, do we know what to do with it? That's really the most important part. It's easy to factor. It's a difference of squares. So we get x plus 2 times x minus 2. So here's a little hint on these. If after you factor, you don't have anything to cancel, you didn't factor right. Okay, because the whole purpose of what we're doing right now is to factor and reduce, right? So, but here I can cancel those two. So then I still have the limit as x approaches 2 of, and then that's x minus 3 over x plus 2. Now that it's reduced, I can do my direct substitution. So this will give me 2 minus 3 over 2 plus 2. And that's negative 1/4. Okay. Any questions at this point? All right, so let's look at number 4. On number 4, I have to factor, but in the numerator, I have 4 terms. So what do I do in that situation? What's it called? Factor by what? Grouping. Okay, good. Now, remember I said your notation's important. You can't have chicken scratch all over the place and just random things. It is okay to kind of go off to the side and do something and kind of put it back in, but you have to actually go off to the side to do it. I can't have this, do some random stuff right underneath it, and then come back to the limit notation, because then it looks like that's your train of thought, and it doesn't really make sense equality-wise. Does that make sense to you? So if you want to, you can say, all right, I'm going to take this, I'm going to go over here. We don't really have an off to the side much over here just because of the space, but oh my gosh. And I'm going to factor this by grouping before I move on to my next step, right? So if I do that, this is going to give me x squared times x plus 4 minus 1 times x plus 4. And then that gives me x squared minus 1 times x plus 4. Okay? So I factored it. Basically, we can go off to the side to do something that I wouldn't necessarily have to show the steps for. I mean, if you can look at that and jump to this step right here, that's fine too. And then now I can say, all right, so that means that the limit as x approaches negative 4 of, it gives me x squared minus 1 times x plus 4. And then the denominator.
Still learning, huh?
Still learning. School's not over. All right, so then the denominator, I have 2x times x plus 4, right? Now, can I factor the numerator more? Yes, because I have difference in squares again. Does it look like I need to? No, because I can cancel this out, right? And I know that if I did factor this, it's not going to help me cancel that out, so there's no need to. If you do, that's fine. If you don't, that's fine. Because we're not factoring it because it says we have to factor. We're factoring it because we need to be able to reduce. Make sense? So we can just leave it like that, and this becomes the limit as x approaches negative 4 of x squared minus 1 over 2x. And I actually could have dropped the parentheses in the numerator. I just wrote them. It really doesn't matter either way. Okay. Now I can evaluate. So this is going to give me negative 4 squared minus 1 over 2 times negative 4. So it'll be 16 minus 1, that's 15 over negative 8. And that's all I can do. Okay. Or negative 15 over 8, like it doesn't matter. Any questions at all? We good? Just got to be able to factor and keep up with your stuff, right? Okay, so let's look at number 5. So this is going to equal the limit as x approaches 6 of, so in the numerator, I've got x and x. 24 is negative, so the signs are different. So it looks like that should be a negative 6 and a positive 4. Right? Now in the denominator, I got to factor, and a is not 1, right? So I would factor by grouping here too, or if you have a different method, that's fine. I think most of us do factor by grouping. So 3 times 12 is 36. So I'm going to come off to the side here and do my little factoring. So I need 2 numbers that multiply to give me 36, combine to give me 20. Negative 20. 18 and 2. So negative 18x minus 2x plus 12. So that'll give me 3x times x minus 6, and then minus 2 times x minus 6. So I get 3x minus 2 times x minus 6. Hopefully, some of you, a lot of you, will get to the point where you can kind of go straight from here to here without doing this, if you just kind of by reasoning through your numbers. But there's nothing wrong with going through those steps. And to actually show it in the middle of the whole limit notation would be a nightmare. So coming off to the side, doing something that we wouldn't necessarily have to show the work for, and then putting it back in. So this is 3x minus 2 times x minus 6. Okay. Then we're going to cancel those out. So that leaves me with the limit as x approaches 6 of x plus 4 over 3x minus 2. Then I can evaluate. So this is going to give me 6 plus 4 over 3 times 6 minus 2, which is going to give me 10 over 16, which is 5/8. Any questions about that? All right. So let's look at number 6. When I factor number 6, what's that in the numerator called? Sum of what? Cubes, right? So let's take care of the denominator first. We've got the limit as x approaches negative 2 of, so in the denominator, I have x and x. This is positive, so the signs are the same, so they're both positive. Be 2 and 10. That's a piece of cake, right? So then in the numerator, when you factor a sum of cubes, you're going to get a binomial times a trinomial. And remember SOAP, same, opposite, always positive. And I'm going to give you a minute to challenge yourself and get that factored. You know how to do this. Dig back in the back of your brain if necessary. And remember that our whole purpose of what we're doing is so that something cancels out, right? So chances are really good that that little binomial in the top is either x plus 2 or x plus 10. Otherwise, we wouldn't be able to cancel anything out, right? So y'all get that far. I'll come back up and work it. Let me go check well before I forget, because I will forget. Actually, let me pause the video. I guess it take too long. Alrighty, so I know that my signs are same, opposite, always positive. That's what SOAP means. Then I take the cube root of each. The cube root of x cubed is x. The cube root of 8 is 2. This first term, I square the x and get x squared. Then I multiply these two together and get 2x. Then I square the 2 and I get 4. And that's what it should look like. Okay? Yay! And then now I can cancel those. And this gives me the limit as x approaches negative 2 of x squared minus 2x plus 4 over x plus 10. Then I can evaluate. So this is going to give me negative 2 squared minus 2 times negative 2 plus 4 over negative 2 plus 10. So this is going to give me 4 plus 4 plus 4 over 8. That's 12 over 8, which reduces to 3/2. Any questions about that? Good. All right, so then when you're done, you can flip it over. Remember, if you're watching the video, I know the back of yours is most likely blank, but don't stop here. Okay? You will be sad if you stop here. Okay, so now we are going to do some rationalizing examples. Now, we know how to rationalize the denominator. If we got a square root of 2 in the denominator, we know to multiply by the square root of 2 over the square root of 2, right? Here, we're not rationalizing because it's illegal to have the square roots where they are. We're rationalizing because if you look at number 7, if I substitute in 4, I'm going to get 0 over 0. But there's nothing to factor like I did on the front, right? But since I have square roots, I can rationalize. And we rationalize using the conjugate, which is something that you did learn in Algebra 2 when you were rationalizing. So you may not have rationalized stuff that looked like this necessarily, but they probably didn't have variables, and it was probably more like the square root of 3 minus 2 or something like that. But either way, we need to understand the conjugate and how to get it. So we can find the conjugate of anything. It doesn't have to be a square root necessarily. So let's say that I have x plus 3. And I want the conjugate of x plus 3. All I do is take my binomial in the middle, I change the sign. So the conjugate of x plus 3 is x minus 3. See how easy that is? It doesn't get any more complicated than that. You change the sign in between the two terms. Now look at what you have. We're doing that so that we can multiply it together and do some things with it. When I multiply these two, I have x plus 3 times x minus 3, and that's a difference of squares, right? So I'm pretty confident that if you multiply those, you know what the answer is. But I want you to actually think, and you probably don't even really think about the process anymore, and that's fine. But I want you to think about the process, because we can apply it to any kind of a difference of squares. It doesn't always have to be this simple. When you have this situation, you square the first term, which gives me x squared, and then it's minus, that's why it's called the difference of squares. Then you square the second one, that's why you get x squared minus 9. Like, that's actually the process in the rule, okay? Because we're going to do it with square roots, it's going to be a lot easier than it looks. Like, this is going to look pretty yucky because of the square roots. That doesn't mean it's difficult. That doesn't mean it's probably easier than some having to factor on the front if you struggle with factoring. It's not that bad. It just doesn't look that great, okay? So let's look at this first one. So since I will get 0 over 0, I want to multiply by the conjugate of the square root part, so the numerator. So basically we're rationalizing the numerator. We usually rationalize the denominator. Again, it has nothing to do with, it not being allowed in the denominator. It's more about we're trying to get something we can handle here. So I'm going to multiply by the conjugate. The conjugate of the square root of x minus 2 is the square root of x plus 2. So I multiply by the square root of x plus 2 over the square root of x plus 2 because that has a value of 1. Therefore, I'm not changing the value of the fraction. I'm just changing the way it looks. Okay? That makes sense? So now I rewrite the limit as x approaches 4 of, now look in the numerator, because that's the conjugate, I have a difference of squares situation, right? So I square that first term. When I square the square root of x, I get x, right? Then minus, and I square the 2, I get 4. In the denominator, yes, I'm multiplying them together, but I don't have to actually distribute things out because I actually want it factored. So this gives me x minus 4 times the square root of x plus 2. See how that worked out nicely? Now can I simplify my fraction? I can, right? I can cancel this out. So now I have the limit as x approaches 4 of 1 over the square root of x plus 2. Now when I do direct substitution, I won't get 0 over 0. Okay? I didn't change the value of the fraction. I changed the way it looks because I multiplied by a value of 1. When I do direct substitution now, this is going to give me 1 over the square root of 4 plus 2, which is just 1/4. What questions do you have? Not that bad, right? Not that bad. It looks weird, not that bad. So don't freak out just because it looks weird or because it has square roots in it, and don't make up any math. Okay, so let's look at number 8. The square root here is in the denominator, so that I want the conjugate of the denominator, so that's the square root of 4x, and then plus 6. So in the numerator, that's also the square root of 4x plus 6. So then this is going to give me the limit as x approaches 9 of, now in the numerator, I'm just going to leave it as x minus 9 times the square root of 4x plus 6. In the denominator, I have a difference of squares. So I square that first term, and that'll just give me 4x minus, I square the second term, and I get 36. Now, at this step in number 7, I was able to cancel some stuff out. I can't here, but do you see potential for that? Right? In the denominator, I can factor out the GCF, right? So this gives me the limit as x approaches 9 of x minus 9 times, so I have to rewrite everything in the numerator, and then the denominator, that gives me 4 times x minus 9. So now I have something I can reduce, right? So I'm going to reduce this, and this gives me the limit as x approaches 9 of the square root of 4x plus 6 over 4. Then I can do my direct substitution. So this is the square root of 4 times 9 plus 6 over 4. So 4 times 9 is 36. The square root of that is 6. And 6 plus 6 is 12. Divided by 4 gives me 3. What questions do you have? Anything? You just got to be able to keep up with your work. You got to be able to read your own handwriting and make sure that your notation is correct along the way. Know when to drop the limit and when not to. Okay? We all good? Any questions? All right. So before I scroll too much, look at 9 and 10 and see how they're different from 7 and 8. In 7 and 8, under the square root, we just had one term. In 9 and 10, under the square root, we have 2 terms. Okay? So it doesn't really change our process much, but you got to make sure that you use the conjugate correctly. Meaning that when I'm here and I want to multiply by the conjugate, I am not changing the sign inside the square root. Whatever's inside the square root stays exactly the same. It's the sign between the 2 terms that changes. So this is still the square root of x plus 1, but on the outside it becomes plus 1. And then I get square root of x plus 1, and then plus 1 on the outside. So just make sure you're changing the sign in the correct place. Okay? We okay with that? All right, so then I get the limit as x approaches 0 of, in the numerator I have negative 3x times the square root of x plus 1 plus 1. In the denominator, I have a difference of squares again. When I square the square root, I'm going to get x plus 1, and then minus, I square the 1 and get 1. Okay, that makes sense? I squared the square root. When I square that, I get x plus 1, minus, then I square that 1. That's where that 1 comes from. So that means this is equal to the limit as x approaches 0 of negative 3x times the square root of x plus 1 over x. Because this x plus 1 minus 1 just leaves me with x in the denominator. So then I can cancel out these x's, and that leaves me with the limit as x approaches 0 of, well, actually I don't even need my fraction bar anymore because my denominator is gone, right? I just have negative 3 times the square root of x plus 1 plus 1. Now, you could have skipped some steps. I don't like skipping steps in the notes because I don't want to lose you when you're looking down and looking back up. But when you saw here that this is going to become just x, you could have canceled it out at this step and then jumped it. That's totally fine. It's not about showing every single step as far as your notation is concerned. It's about showing enough of your process that it makes sense and you not making things up. But again, on the notes, I just don't want to lose you. Okay, so now that I have it all simplified, now I can evaluate. I'm going to substitute in that 0. I'm going to get negative 3 times the square root of 0 plus 1 plus 1. All right, so the square root of 1 is 1, plus 1 is 2, times a negative 3 gives me negative 6. What questions you got? Anything? Good? All right. So let's do 10. I'm going to multiply. This is going to be the square root of 14 minus x. Remember, we do not change the sign inside the square root. We change the sign between the two terms. So this will be plus 4, square root of 14 minus x plus 4. So I get the limit as x approaches negative 2 of, and then in the numerator, it's x plus 2 times the square root of 14 minus x plus 4. Now in the denominator, difference of squares, right? I square the square root, and that gives me 14 minus x minus, and then I square that 4, and I get 16. Okay, so make sure you're keeping up with your pieces so you're not making up numbers or anything. Everybody good at this point? So I'm going to clean up that denominator. This is going to give me the limit as x approaches negative 2 of, numerator, I have to rewrite it all every time, square root of 14 minus x plus 4. So in that denominator, it's going to give me negative x minus 2. Now, I can't cancel anything out at this point, but can I make this denominator end up with an x plus 2 in it? Yeah, because I can factor out a negative 1, right? So this is equal to the limit as x approaches negative 2 of, got to rewrite it all again, x plus 2, square root of 14 minus x, and then plus 4 on the outside, over negative times x plus 2. Factor out that negative 1, right? Oops. So now I can cancel these out, and then this leaves me with the limit as x approaches negative 2 of square root of 14 minus x plus 4 over negative 1. Now, or you could have put the negative. You got to be careful putting the negative out front. You'd have to leave the parentheses there. It's safer just to kind of leave it where it was and do your thing. So I'm going to substitute that in that negative 2. So I get the square root of 14 minus a negative 2, and then plus 4 on the outside over negative 1. So 14 minus a negative 2 is 16. Square root of 16 is 4. 4 plus 4 is 8, and that's a negative 1. So my answer is negative 8. Right. What questions you got? Anything? Okay. We all good? Let's look at number 11. All right. So I'm going to multiply by the conjugate. So this is going to give me the square root of 2x plus 15 minus x over the square root of 2x plus 15 minus x. This equals the limit as x approaches negative 3 of, now my difference of squares is in the numerator. So I square that square root, and I get 2x plus 15. Then minus, I square the x, and it's x squared. The denominator is going to be x plus 3 times the square root of 2x plus 15 minus x. Everybody good so far? Nothing to cancel out at this point, right? And the numerator is a quadratic, so I think I'm going to need to factor that, so I need to put it in the correct order. So this is going to become the limit as x approaches negative 3 of negative x squared plus 2x plus 15. Then the denominator is still x plus 3 times the square root, 2x plus 15 minus x. Okay, a lot of writing, a lot of weird looking stuff does not mean that it's difficult, so don't try to make it difficult. All right. Now in the numerator, I want to factor that, but I would really like that first term to be positive. So I'm going to factor out a negative. I'll get the limit as x approaches negative 3 of negative, and then x squared minus 2x minus 15. And then I rewrite everything else. Now I'm going to factor that numerator. So it's going to give me the limit as x approaches negative 3 of, so this negative, and then two binomials, x and x. That 15 is negative, so the signs are opposites. That'll be a negative 5 and a positive 3. My denominator is x plus 3 times the square root, 2x plus 15 minus x. Everybody with me? Any questions? All right, so now I can reduce this. I got to be careful with that negative and that x minus 5. I can't just drop those parentheses without dealing with the negative, so I'm just going to leave it like it is. So this will be the limit as x approaches negative 3 of, in the numerator I have negative parentheses x minus 5. And then I have, in the denominator, what I have left is the square root of 2x plus 15. Oops. 2x plus 15 minus x. Okay. Everybody good with everything? So now everything is reduced and simplified, and I can evaluate. So this is going to give me negative, and then negative 3 minus 5 over the square root of 2 times negative 3 plus 15 minus a negative 3. All right, just substituted in my negative 3. So in the numerator, negative 3 minus 5 is negative 8. I make that negative. That means it's a positive 8. Then in the denominator, 2 times a negative 3 is negative 6, plus 15 is 9, square root of 9 is 3, minus a negative 3, that's 3 plus 3. That's going to be 8 over 6, which is going to reduce to 4/3. What questions do you have? Anything? You got this, okay? A lot of algebra, but you just keep up with it. It's not crazy. It looks terrible, but it's not really that bad if you can just keep up with what you're writing, okay? We good? All righty.